Circle geometry. What is circle geometry? It is all about circles and theorems. The knowledge of circles helps us understand the theorems, and the knowledge of the theorems help us to answer questions in circle geometry. These questions are called riders. So in circle geometry, we solve riders. So let's begin with circles. A circle is drawn with center O. A line drawn from the center of the circle to anywhere on the circumference is called the radius of the circle. If a line is drawn from one point on the circle to another point on the circle and passing through the center of the circle, it is called a diameter. So the diameter is 2 times the radius. Now, a line drawn from one point on the circle to another point on the circle and not passing through the center of the circle is called a chord. So line AB is a chord. A chord divides a circle into 2 segments, the minor segment and the major segment. So chords are very important in circle geometry, and it is important we understand it. So let's elaborate. This is a chord drawn to this circle called AB. The chord divides the circle into 2 segments, the minor segment and the major segment. So if this chord subtends an angle C, this angle is subtended in the minor segment. And if the chord subtends an angle D, this angle is subtended, angle D is subtended in the major segment. So when we talk about chords, we talk about segments. The chord divides the circle into 2 segments, the minor segment and the major segment. Now we talk about arcs. An arc is the distance between 2 points on a circle measured along the circumference. So this is an arc of a circle. The distance from point A to point B measured along the circumference of the circle. A chord is a line and an arc is a part of the circumference of the circle. Now you understand the difference between an arc and a chord. Finally, we talk about a tangent. A tangent is a line drawn to a circle and touching the circle at a single point. This line is drawn to the circle and touches the circle at a single point. At this point, let's call the point, let's say point E. A line drawn to a circle and touching the circle at a single point, we refer to it as the tangent to the circle. Now, let's talk about the circle theorems. So I have divided the circle theorems into 3 parts. The part that talks about arcs and chords, another part talks about cyclic quadrilateral, and another part talks about tangents. This is for easy understanding. So we will begin with the part that talks about arcs and chords. There are 5 theorems that talk about arcs and chords. The first theorem says a line drawn from the center of a circle. This is the center of a circle. A line drawn from the center of a circle perpendicular to a chord bisects the chord. So this is a chord AB, and the line drawn from the center of a circle perpendicular to the chord bisects the chord, divides the chord into 2 equal parts, and we refer to this theorem as perpendicular from center to chord. Now a second theorem says if an arc AB, remember what an arc is? If an arc AB subtends an angle at the center of a circle. This angle AOB is 2 times the size of an angle subtended by the same arc on the circle. So this is angle C. Angle AOB is 2 times the size of angle ACB. So if the size of this angle is x, the size of this is going to be 2x. So angle at the center is 2 times angle at the circumference, and this is how we refer to the theorem. Angle at center is equal to 2 times angle at circle. Now the third theorem. This theorem says, a chord or an arc subtends equal angles. So this is an arc AB, and this arc subtends an angle on the circle. The theorem says the same arc subtends equal angles on the circle. So arc AB subtends angle C on the circle and also subtends angle D on the circle. Now the theorem says angle C is equal to angle D. An arc subtends equal angles on the circle, on the same side of the circle. So we refer to this theorem as same arc or equal arcs. Now the fourth theorem. This theorem says equal chords subtend equal angles. So we have a chord AB and we have another chord CD. If these two chords are equal in length, then the angle subtended by chord CD in the major segment is equal to the angle subtended by chord AB in its own major segment. So chord CD subtends the angle E in the major segment, and chord AB subtends the angle F in the major segment. So the theorem says the size of angle E is equal to the size of angle F because the chords are equal in length. So we refer to this theorem as equal chords. Equal chords subtend equal angles on the corresponding sides of the circle. Now, theorem 5, we talk about diameter. The theorem says the diameter of a circle, this is the diameter of a circle with center O. The diameter of a circle subtends an angle 90 degrees on the circle. So if this is the diameter of a circle, the size of this angle is 90 degrees. The diameter of a circle subtends angle 90 degrees on the circle. We refer to this theorem as angles in a semicircle. So these are the 5 theorems on arcs and chords. Now we move over to the next theorem. So another part of the theorem deals with cyclic quadrilateral. So what is a cyclic quadrilateral? If 4 points of a quadrilateral lie on a circle, the quadrilateral is referred to as a cyclic quadrilateral. If the 4 points of a quadrilateral A, B, C, D lie on a circle, the quadrilateral is referred to as a cyclic quadrilateral. So the first theorem, theorem 6 on cyclic quadrilateral, says the opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees. So if the size of this angle is x, then the size of the opposite angle is going to be 180 degrees minus x. So the opposite angles of a cyclic quadrilateral are supplementary. Now, if we extend the line DC to E, what is the size of this angle? if the size of this angle is 180 degrees minus x, what do you think is the size of this angle? This angle is going to be x, because angles on a straight line add up to 180 degrees. So we have 180 degrees minus x plus x. Let's see, this is equal to 180 degrees minus x plus x. And these x's cancel out, minus x plus x cancel out. So the size of this angle is 180 degrees, which is the size of angles on a straight line. So this is angle x, and it follows that we can say that this is also angle x. So this is angle x and this is angle x. Now we have a corollary that says the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So we refer to this as a corollary. It's not a theorem, but it is derived from the theorem 6, that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So angle x on the side, angle BCE, is the size of angle A on the side. So these theorems are related to cyclic quadrilateral. Now we talk about more theorems. So the next set of theorems talk about tangents. Theorem 7 says the radius is perpendicular to the tangent. So this is the radius of a circle from the center O. The radius is perpendicular to the tangent. Now theorem 8, we refer to theorem 7 as radius perpendicular to tangent. Another theorem, theorem 8, says if two tangents are drawn to a circle from the same point outside the circle, then the tangents are equal in length. So this is a tangent AP, another tangent BP, drawn to the circle coming from the same point outside the circle. The theorem states that the two tangents are equal in length. Now the last theorem on tangents says if a chord is drawn to a circle, from the same point of a tangent, this is a chord AB, drawn to the circle, the angle between the chord and the tangent is equal to the angle subtended by the same chord in the alternate segment. So this is a chord AB, drawn from this point where the tangent meets the circle. The theorem says the angle made by the chord and the tangent, angle X, is equal to the angle subtended by the same chord in the alternate segment. So here is the minor segment of the chord. This is a chord. Remember, a chord divides a circle into two segments. This is the minor segment. So the size of this angle made by the chord and the tangent is the same as the size of the angle subtended by the same chord in the alternate segment. So angle C is equal to X, the same size as angle AB, let's call this D, ABD. X is equal to X, and this is the alternate segment. So we refer to this theorem as tan-chord theorem. We refer to theorem 8 as tans from same point. So these are the three theorems we have in circle geometry which relate to tangents.